Good morning. Hopefully you can hear me out there. Welcome to all of you guys back out there again that are tuning in for another Tebis webinar. We hope that you are going to be enjoying this particular episode and this particular webinar, which is a very interesting topic to discuss, especially during the course of this pandemic. I mean, if you would have asked me at the beginning of February that in August we'll be still dealing with this particular situation, I would have called you a fool. But unfortunately, we're still here. And this is where digital twins and this technology really comes very strongly over to you. And potentially you are asking, well, how beneficial is this particular topic or this digital twin for my organization? And I can tell you these are one of the items that I believe is one of the absolute musts and the absolute must-haves for any company in today's society. My name is Michael Thiessen. I'm the sales manager here at Tebis America, and I will be moderating and hosting this particular event for you. Hopefully you will enjoy it as much as I will, and hopefully you'll get something out of it. And that you are enjoying this particular topic. Well, let's get into this particular item, but before I'm going to go into more depth, if you have missed any of the webinars in the past that we have done, please visit us at tebis.com. Several other items, if audio does not come through well for you, except of that little snafu at the very beginning, where my microphone was still turned off. Hopefully this is now all beside each other, but if you should have some audio problems, please also utilize the dial-in functions that you have available during your registration. Secondly is I will be turning off my webcam, excuse me, in order to help out with any of the transmission problems that we're going through. Obviously everybody's using the internet nowadays, and these are one of the ways that we can help out in making sure that you get the most out of it during this webinar. And last but not least, obviously, we appreciate always, as every single time, your questions, your items as you're going through this webinar. Please put them in your question box. I've seen already a couple of questions that have come in, thanks to the audio issues. But utilize the question box throughout the course of the webinar, and I will get to these questions at the end of this particular webinar. So just to give you a little bit of a background, not about me, but a little bit about who Tebis really is and why we are in this particular aspect of digital twins such an important item. Well, you will find us in the majority of the mold and die manufacturers here in the United States, but also globally and worldwide. These are some of the major industries that we are very much a part of, and companies that utilize our products recognize of what kind of power and what kind of technology we bring to you as our clients and as our customers. But that's not just in the mold and die industry, but also in the model industry and the studio industry. So these are industries that are very heavily utilizing milling, machining, manufacturing as a whole, as well as in the aerospace industry, as well as in the production machining industry. We provide a very essential level of know-how and knowledge and technology that I would say a lot of the other software solutions do not provide, and we're fortunate enough to have a lot of our experts on hand to assist with all of these particular services, if these are implementation services or consulting services for that matter. We're not a small company by all means, but we have the complete solutions for every single process that you are looking for, and these are always processes that make you as a customer more efficient. So we have over 200,000 customers worldwide, over 9,000 installations of Tebis installed with happy customers. So if you have not yet looked at Tebis, I urge you, go ahead and look at this. If you want more information, go to our website, as you can find a lot more information on that particular site. This website has been completely redone just at the beginning of the year. And if you've not yet gone onto this particular website, I urge you to do this. Anyways, let's get to the real topic. And this is where I'm going to now turn off my webcam. So therefore, you can really focus on what we're trying to go through and go over. So let's get right into it. Digital twins. You probably have heard this term before. You may have not. For all of you guys that have joined me in our last webinar with Hardware Results, who I appreciate very much, we also talked about a very brief version of digital twins, but if you've seen this, some of these slides may be somewhat similar to you, and you may have recognized this. So I went to our Wikipedia online in order to get a very good understanding of what a digital twin is. And you can read there what the terminology of the digital twin actually is. It is essentially a exact digital replica of all of your physical devices that you're using for milling and manufacturing, etc. Some companies or some items call it an avatar, which of course is very similar to it. But a digital twin represents all of your operations and all of your items that you use from a physical product into a digital product. So having that out of the way, knowing exactly what we're dealing with these digital twins, is this particular term, this digital twin term, a complete new term that just came out because of Internet of Things or the Industry 4.0, which are all buzzwords that we're hearing in the industry? And I have to disappoint you, unfortunately, that this particular term, digital twins, or these avatars that are out there for you in these various systems, is not a new term. We've had this term already for a very long time, and actually, I think all of you are using a digital twin today. This has been around since the very beginning of CAD CAM, which is your job, the part that you are creating. So this particular CAD model in a digital form is your digital twin that you're dealing with. So it's not just a picture on your CAD CAM system that it gets displayed, but this particular item has a lot more technology embedded in the system in this particular part. Technology items in terms of understanding what kind of tolerances you're dealing with. Technology that you know of, what is critical to your operation and what is not. That also gives additional information to the various departments that you're dealing with. So today, in today's society, with today's CAD CAM systems, this particular job, this particular part in your CAD CAM system has way more technology than what you've had back in the 80s. And just to give you a little bit of a look back on the Tebis side here, of where did we utilize these digital twins and how soon did we do this? Already early on in our version 1.0, which came out, by the way, in 1984, we were one of the first CAD systems out there. You had a digital twin, which was the 3D CAD model, as we already spoken about, as well that represented your part, which is the real component. Also, from the tool library, also, of course, which looked very primitive probably at the time, we had a tool library that companies were able to do, as well as a post-processor that corresponded to the controller in its format that the controller can accept. In version 2.0, we utilized 3D machine head models inside of our system in order to aid with the visualization of your machine head. In version 3.0, we came out with more enhancements to our tool library in order to create a virtual representation of your tools, to have a virtual tool crib, as we call it nowadays. And then in 2004, with our solutions for simulation equipments and virtual machine technology, we brought to you the utilization of virtual machine models to represent exactly your machine for the purposes of somewhat lights out machining and more realization. Then we came up with what we call a unit library or an aggregate library in order to assist with components for mill turns and turning, such as chucks and items like that. And then very soon you will be receiving a new version, which will be coming out here very, very soon, that will also entail a clamping device library to bring even more realism to your operation, more digital twin technology. We already talked about the part, or your part is not the only item that you have as an important item, but also your tooling equipment. Nowadays, the tooling technology has really gone beyond boundaries of what you can do with them, and the capabilities are absolutely phenomenal with some of these tooling manufacturers. We did a survey to give you a little bit of a content on at the end of 2019, just to give a little bit of an idea, how is the industry working with these particular digital twins? And this particular question was asked to the participants of this survey. This was done by Tebis AG in Europe. Do you use virtual tool assemblies for the NC programming? And I can tell you the majority of 87% said yes, we're utilizing virtual tool assemblies, including holders, extensions, and cutters, of course. The rest of them, of these 13%, they still are utilizing just cutter as they are, as we had back then. Why? Well, some of them utilize these particular tooling in material that, such as foam or such a lesser danger areas where it really is not required from their side to have the full tooling assembly available, even though it can probably bring them also additional benefits. So let's look back. Early on, we came out with very simplified tooling. It was just the cutter that had a flute length or a cutting length that we utilized, and that was it. And very shortly, we came out with more component-based milling and drilling tools that really included additional technologies such as feeds and speeds and additional material parameters, so that we can better control its capabilities and what these tools are capable of doing in our system. And then, of course, this goes all the way to component-based 3D turning tools, such as hobbing equipments, live tooling in turning operations, etc. So you can kind of see the virtual tool crib inside Tebis is not just the representation of the tooling itself, but also all the technology that makes this particular tool so powerful and so effective. Now, along with tooling, there needs to be a good way to import these particular tools inside Tebis. Thanks to a lot of these tool management systems that are out there, Tebis integrates with various tool management systems such as Zoller, WinTool, TDM systems that we're dealing with on a consistent basis. So if you have not checked them out, I urge you to look into these tool management systems. But also our tooling manufacturers have really stepped up. Companies such as Moldino or Pocom, as well as a German company called Ora, they have also provided more capabilities to get all of the technical parameters of these tools, and not just the geometry, but also the technical items directly into Tebis in a Tebis format that Tebis accepts. So that brings along all of your feeds and speeds, the recommended feeds and speeds along with it. Check out these particular tooling manufacturers. It makes it a lot easier if these things are there. But then also other systems such as tool data portals, such as Tools United. There's also availability to get this particular import routine or export routine from Tebis directly into our system, and therefore you have immediate information inside your virtual tool crib. An additional item that is very important for increasing the reliability or the realism inside these systems that you're using on a daily basis is of course, besides the part and besides the tooling, of course, your NC machines. I mean, this changed the entire world of the way how we operate and the way how we program nowadays. NC machines, they've become more sophisticated, they have become more powerful, and and you know this probably better than I do, they have been faster than any of the predecessor machines in the past. So with these digital twins, before, what did we use? We used a representation of a head that gave us somewhat of an idea of the way how this head is going to behave. We even had the capability inside Tebis to put a raster to it. So if your machine only operated every degree or every degree and a half, this was able to be represented in there. But this was it for the very long time, until we came out with our virtual machine capabilities, not just only for 3-axis machines, but also for full 5-axis simultaneous machines. If these are gantry machines, if these are table machines, if these are trunnion machines, in Tebis, these types of machines can be represented to its most and highest realism as you possibly can imagine. But this is not where we ended up and where we stopped. We went into more complex type of machinery that goes way beyond than just 5-axis, with gun drills and so forth that have very complex logic for its moving capabilities with multiple heads. Just to give you a little bit of an idea of some of the different capabilities of this technology, I put a small little video together for you. Here we've got a very simplified, or not simplified, 5-axis machine, aerospace machining with a rotating table. Then we go into the capability of turning or mill turning equipment with multiple steady rests and so forth. Going into gun drilling type of capabilities with 7, 8 axes potentially, as well as for the utilization of robot technology to do trimming capabilities, laser capabilities, as well as other operations that you can operate with the robot. But this is not the end. Any kind of complex type of operation, in this case we have a very large gantry machine with a rotating table and doing multiple head changes inside there. All of these things can be represented inside Tebis and represented to its true motion and its true movement inside the machine, in order to make sure that your machines operate as safely as possible. So, digital twins. Here's another question that we had asked. Our members of this particular webinar or this particular survey, again, this is by our headquarters at Tebis CG, do you use virtual machine models for NC programming? And you know what, I'm happy to hear and happy to see that 84% of these participants in Europe agreed that yes, they're utilizing virtual machine models today in order to make their processes more efficient and safer. 16% are using machine independent programming, potentially maybe these machines are 3-axis machines, maybe with operations that are not as critical. So since we are the manufacturer of Tebis, and we also produce for our clients post-processors and these virtual machines, it gives us the availability to kind of look at and see from a global perspective of how the different countries are doing in regards to virtual machines, and who is utilizing more or less and believes in its capabilities. So what we did then is we looked into our archives and kind of looked at the areas of post-processing and post-processing with virtual machines. Interesting numbers came up that in the market of the Europe market, as well as the Emirates and Africa, 100% of them are post-processors, of course, but out of these post-processors, only 44% of them, 44.49% to be exact, utilize virtual machines. Germany is 61.96%. US here, out of the post processors that we have here, our customers that are utilizing them, 51 or close to 52% are utilizing virtual machines with these post processors. And I can tell you actually there's more and more desire and want to utilize virtual machines. And throughout this COVID, this was apparent that virtual machines are becoming more and more important. Over 1,350 virtual machines do we have today at hand for over 250 different types of manufacturers and more than 3,700 variants. So that's quite a bit of a, so to speak, library that we have inside Tebis to be utilized. Obviously, what we saw from this chart, of course, our German compadres that are over in Germany definitely are utilizing the virtual technology more than any of the other countries that we're dealing with the US a close second. So what do we learn out of this? That I think virtual machines, virtual digital twins are going to be more and more prevalent going forward in the future. And I think this is going to be our future in this particular manufacturing environment, that this particular technology is not going away. We also told you earlier, Tebis will be coming out very soon with an extensive library for clamping devices, as well as turning adapters. So keep a lookout for some of the next versions that are going to be released by Tebis. Another way of increasing its capabilities in the area of digital twins and giving you more capabilities to trying to predict what's going to be happening outside on your shop floor, especially in your machines. We all know how this pandemic has been ravaging the manufacturing market, with some companies running with reduced staff, running with reduced operators, and so forth. So this is where we need to utilize technology that is currently available and you make them use for our operations in order to still meet our deadline and produce safely and efficiently our jobs. So we talked about digital twins only so far, with tooling, with your part technology, with your machine technology, and also with your clamping technology. But what about your programming processes? Is that stacking up to its capabilities and to be more efficient? Because obviously, if this particular digital twins and these NC machines would not provide an efficiency aspect for you, you probably wouldn't use it. So this is now where we need to look at the processing, or the way how companies today are processing jobs. And there's three ways that this is possible with these particular virtual machine technology. The first one I'm going to talk to you about is the machine independent NC programming. Then post-processing before the verification of the toolpaths. What do I mean with this? So you have a job that you have to machine. You're utilizing a machine independent programming solution, which means you're not utilizing the virtual machine at all. You're utilizing maybe a head technology in order to make your toolpaths. After these toolpaths are then created, you then post-process these particular jobs, utilizing your post-processors, if this is for your Siemens controllers, or if these are for Heidenhain or for Nook, whatever there is, you do your post-processing translation, and then you utilize a secondary system for the NC program simulation. It could be on a different computer. It could be actually at the machining department now, that at the machine now you're looking at this verification. And then afterwards, you have then potentially correction solutions that you need to do. So there's two ways that you can handle these correction solutions in case there's a problem. First of all, it comes to a halt. You need to kind of determine what can you do at this time. And more times, this goes now back to the CAD CAM operator again, to the programmer, to say, make some changes in this particular toolpath in order that it is safe to run on this particular machine. Or the individual can handle it directly himself or herself and make the adjustments directly in this particular simulation equipment. Okay, so you can see that there is this process loop that has to go through, and only once this particular person then deems it as adequate, I can then go through and give it to my machine for processing on the machine. So this is one way that clients out there or customers out there are utilizing this particular solution. There's a second one, and that is the machine independent NC programming, and then the toolpath verification in the same CAM system. So how does that look? Let's take a look. You have, again, your machine independent NC programming. You're not utilizing the full capability of that particular virtual machine. You're just utilizing your tooling equipment, you're utilizing your head information, and you start making your toolpath by maybe limiting toolpaths, etc. You then go into a subsequent simulation system, maybe in the same CAM system, and then I now apply these toolpaths to this particular machine. And then I verify if these jobs or if these toolpaths are okay to be run. Hopefully you're still following along so far. If I find a mistake, now I need to go back to my CAD CAM system. Since I'm the same person that does it, I have to go back to my CAD CAM system, make some adjustments because the machine capability maybe cannot handle this, or maybe the tooling is too long to deal with it, or in terms of turn melts or turning equipment, now all of a sudden my tool crashes into the part because it has a rotary turret, and you need to adjust this. Only after this adjustment is done, you can then say, yes, everything is fine. I can then post-process out of my system and then go to my NC machines. The third one, since I said there were three, is the capability of utilizing right from the beginning machine-dependent capabilities. So right when starting, the first thought that you should have is, what machine am I putting this on? And what are its capabilities? And what are all the items that I'm utilizing? And then verify in the same CAM system the NC code. Of course, this is the Tebis philosophy. I'm not beating around the bush here, but this is the capability of utilizing these machine-dependent NC programming solutions where I'm utilizing in my machining solution right from the beginning, and I can plan inside the Tebis simulator. Will it fit on the job? How many setups do I need to make? What kind of clamping tools do I need to have? And then I can utilize my digital twins for my tooling equipment, for my clamping equipment. I can determine which machine should it go on. Do I need to have a riser on this particular machine or not? And then select my digital twins for the NC machine in order how to set this up and determine where my clamps need to go in order to process this particular job as efficient as possible. So right from the get-go, the Tebis programmers immediately in their machining select their jobs, select their setup routines, select their machine. So what you're actually doing is you're programming with the machine at hand, as if you are teleported into your machine and you can already determine before anything happens while you're making your toolpath of its capabilities and what you can do. Obviously from there then I'm feeding this directly into my process. I can then post-process out to my machines then, and you can potentially already see that this particular process is a very smooth, direct, forward-looking process that a lot of the other systems that are out there are not fully utilizing and not making this as efficient as they can be. Again, also there, a survey was asked to these attendees, how do you check your NC programs? And of course, you immediately see why are there not three items, as I said? Why is there a fourth item? Well, the fourth item is very specifically in the aerospace industry. There's the mandate that not only is a internal verification system necessary, but also a secondary virtual simulation system needs to be there if that is on the controller of the machine, or a secondary simulation system that also comes into place. Let's look at the percentages that we said. 9% of them use a machine independent programming, so I'm very happy to see that they're already looking at this. Mind you, a lot of them were probably Tebis utilization, so they already did utilize this, but 69%, the majority of these particular attendees utilize the virtual machine models right from the get-go, right from the beginning, in order to make a very positive impact on its efficiency. 13% of them, however, utilize the secondary simulation software afterwards. Like I said, a lot of the aerospace industry demands this, and we have several customers that are doing this today in order to get these particular very delicate models and very expensive models machined with Tebis. Well, again, I said these three items is the way how we program today. Is one better than the other, depending on the way how you're operating, of course, is key. However, obviously, we all try to be more efficient, more forward-looking, making sure that our machines are safer with its processes and with the jobs that are at hand. Obviously, the Tebis philosophy really pushes this to its limit, and there's a lot more stuff actually in the pipeline from development to give the customers even higher realism and higher capabilities with these particular digital twins. So again, another question was asked. I wanted to give you that information here as well. What do you think is the most reliable procedure, or the safest procedure out of these items that we have earlier already brought to you? Again, these are the same 4 topics. 69% of these people that were surveyed think that programming with virtual machine models is, of course, the safest process, because you have all of the entities at hand, you have your clamping devices at hand, you have tooling equipment at hand that has proper safeties, proper step overs and feeds and speeds. Then you have 20% believe that programming with virtual machines and then verifying in the same CAM system that this is a safe process. And then, of course, you can see the other 2 items for yourself. One more entity, what do you think is the most efficient procedure? I think this is more of a loaded question. I think you can kind of imagine already from what these particular individuals would vote on what is the most efficient procedure. Of course, the Tebis process or the Tebis philosophy definitely, without a doubt, is the most efficient programming process in its reliability, in its safety, and its capabilities outside on the NC machine that goes way above anybody else's capabilities. 10% do believe that machine-dependent verification before NC output is a efficient process, and then 12% utilize the latter. So you can kind of get the idea. We always need to look at capabilities of technology, especially during this pandemic that we're finding ourselves in trying to utilize technology to its biggest impact. And always the biggest impact is always the saving of dollars. So obviously there's some weaknesses. What are some of the problems that we're running into? In all 3 of these items, or even 4 of these items, the post-processor is your limiting factor. I'm not lying to you here, but the post-processor is probably your most limiting factor. Having a reliable and safe process with your post-processor is key. And there, you know what, there's so many companies that have said to you, well, you know what, if you are post-processing before you're simulating, who guarantees that this post-processor is good? Well, the answer is always Tebis has a way, a process, a verification process that when we go through we do acceptance testing on the virtual machine process as well as on the post processor. We make sure that we go through our checklist of all potential capability flaws and catch them in our test acceptance. So we are actually on site verifying that the machine, first of all, is accurate, and then verifying its post capabilities depending on what your needs are. And I'm happy to say that our post writers are probably one of the most expert post writers that are out there. And we can put stuff into our posts that other systems simply cannot. I mean, that's just the simple fact. So having these acceptance test parts employed to all NC programs and all of its variants is key. Only then, if you verify the machines, and we're not like other systems that are out there that are just accepting the manufacturer's model for your machine, because we've already proven numerous times to clients that some of the models are not accurate from the manufacturer. And we only find that out when we measure these machines through our ways of determining and measuring these machines. But only when we go through and accept the virtual machine and accept the post processor and a document is then provided, you then output via our tested and verified post processors, and you provide these particular items then to the machine. So these are very key aspects, and only from what I know of, Tebis is providing this particular service to our clients, that we take our virtual machines and getting these virtual machines tested by our team. Our team comes in, we have our machinery in order to test these machines, and we have a checklist that actually you can also see and verify, and you are an integral part in this particular process. And obviously every single capability that your machine has, we want to implement in our post processes and implement into our virtual machines. If you've not yet dabbled with digital twins, there are 4 easy steps for you to get started, okay? And some of the questions that you need to ask. First of all, if you have a CAD CAM system that is capable of doing this, utilize this technology. If you don't, make sure that these digital twins have enough information in it to make it worth your while and have the capabilities in order to get you to this next level, because this next level is coming, believe it or not. The utilization of just the head by itself is going away. The industry is just demanding this. Second item that you need to make sure is clarify that the data that comes in from your manufacturer is true, that you get all this information in, and also which interfaces are needed. Also on your parts, for your digital parts that you bring in, make sure that the interfaces that you're using are top of the art, that brings all of the the geometry models in. With Tebis, we have direct interfaces to a lot of the design systems that are out there that can ensure this. Make sure that you avoid these iteration loops that we talked earlier, that you constantly have to post out, verify, and then go back again. These iteration loops cost you a ton of time. Do it inside the same system that you're programming with the machine-dependent type of realization, so that you can get these kind of things already beforehand, because efficiency is key, and that's obviously the biggest item. And also make sure that the support group that you're utilizing for these digital twins, make sure that they have a way to implement these processes, that they come out and potentially do the verification on the machine, verify the post processors, but also can give you advice on automation procedures. And because automation hand in hand with these digital twins really propel you to the front line. And I know what you're saying right now. In my company, we cannot automate. I'm going to tell you that's crap. Sorry, simple words for this, but that's just it. Automation can be done no matter where you are, no matter what you do, because the processes that you do sometimes are repetitive. If that's selecting step over for a certain tool for a certain material, selecting the strategies that you utilize for roughing with the specific tool. In today's design world already, these designers put these particular items already on various layers already, so that you can utilize these layers for automation. Industry 4.0 is knocking at your door. You better be ready. In the US, it's also called Internet of Things. Unfortunately, IMTS this year, as many of you know, has been canceled, but that doesn't mean that you should not be able to get this type of technology. So from that side now, I actually thank you for joining this particular webinar to get more educated in its capabilities, what is out there with these digital twins, and what you can do with this, and how you can make your process much faster. So this brings me at the end of this particular webinar now about digital twins. I'm going to quickly turn my webinar on, pardon me, my webcam on, so you can see actually that that I'm still here, first of all, and I'm still talking to you. I'm glad that all of you guys stuck around for this hopefully very interesting topic, and I sure hope that you got something out of it. If you like, we are available for you. Also, my colleagues in the UK who have also joined in this particular webinar, and truly from the people that have registered, from you that have registered here, many of you guys are from different countries even. I thank you for joining there too. Get in contact with your local representatives of Tebis. If that is my good friend Paul Skelly over in the UK, or my colleagues over at Tebis AG, if you're happen to call in from Germany, please get in touch with them, talk to them about digital twins, see what its capabilities are. You will not be disappointed. Let me get to some of the questions that came in. Of course, I'm ignoring all of the audio issues at the very beginning. Again, I apologize for that very 20 seconds at the very beginning. The question that came in, can you support any type of machine in your simulation? We have not yet come across a machine that we cannot do. I think I'm very safe to say that any type of milling machine, if that is a gantry machine with a W axis, if that is multiple heads that you need to utilize, if these are gun drills with two heads, one for milling and one for drilling capabilities, all of these things can be done. And obviously on the robot side, we can go up to about 8, potentially even 9 axes in doing these things. Of course, robots are still a little bit underutilized and some limited still with vibration and so forth, but a lot of the softer materials, this is definitely a good way on going. There's another question that goes through or was being asked with machine-dependent programming, how difficult is it to make a change to the machine after the program is written? Well, the machine-dependent programming inside the solution, obviously you have all the machine capabilities already beforehand. To go through now and make a change to the program is actually very simple because you're operating in the same job plan or job manager that we have, and immediately it will have an effect on its operation. Matter of fact, a lot of our companies are utilizing its capabilities to very quickly change machines, because obviously your schedule changes a lot, and it can very well easily happen that a machine breaks down. You have still jobs coming through, and now I need to change my programming operations for a different machine. So in Tebis, this can be very easily handled by selecting now your new machine, adapting immediately the programs to that particular machine. A lot of these programs will not have to be recalculated. It will just have to be resimulated. And even the simulation can be done completely off screen. So therefore the efficiency is even higher. For you who asked that question, obviously reach out to me us here at Tebis America, ask for me, and or send me an email, and I will talk to you more in length here. Another question, almost very similar to the line of the machining. Can you create any kind of machine tool? I assume that this represents to the tooling equipment. Yes, I mean, we have not yet also come across a tool or milling tool or drilling tool that we are not able to represent. Even these new technologies for milling, for roughing with these triangular inserts, for these high-speed roughing and high-performance cutters, Tebis is more than capable of handling this, and not just giving you a theoretical display of your tool, but the actual geometry of these tools. So that's very important, that you have the actual tool representation inside the system. Do you also utilize one? Let me see. Do you also utilize machine time? I guess that's what it came across. Yes, obviously the machine time that we're calculating inside the system actually utilizes the kinematic of our machines. It looks at the acceleration parameters, the look-ahead capabilities of your machine. So it's you know what, almost as realistic as you can be. And from our testing that we have done inside here at Tebis, within 5% of its actual machine runtime, if of course the pod is not being adjusted, is real. So from a scheduling perspective, from a ProLice perspective as well, I've not even spoken about that portion of it. ProLice is our MES system that we utilize in our system in order to kind of help out. If you've joined us this last week about the integration of Tebis and the MES, I urge you to go to our website. You can actually see this particular webinar from my good colleague, Marty Chapuy, who has led this particular webinar. But the ProLice solution, the MES solution, really with digital twins and digital twin technology is an incredible solution. So in coming back to cut me off on the tangent with machine times, these are as accurate as you can get. And mind you too, Tebis utilizes not just the collision checking during the toolpath, but also in between toolpaths. So these are very important items to understand. It looks like that no more questions seems to be coming in, or at least there's no additional questions there. I give you about another 30 seconds or so. If another question should pop up, let me know, and I will still answer this. I sure hope that you enjoyed this particular webinar a lot. I hope it was beneficial to you. Send me an email afterwards. Let me know what you think. I also, if you're interested, I have a handout that I can also provide to you with some very important information and critical information for you. For that, reach out to me directly, michael.thiessen@tebisusa.com. That is my email address. Some of you have my email address already. Contact me. I will provide you this particular handout about these digital twins and its capabilities to you, and hopefully that will give you some additional things to think about. With that said, I appreciate your attention. I appreciate that you stuck around until the very end and listened to all of the items that we have to provide to you. Look forward to another webinar that's coming up very soon in combination with my good friends over at Moldino, the Moldino cutting tools, where we're talking about tooling technology, where we are with tooling technology, and how that is a benefit to our machining capabilities and to be even more efficient in combination with these digital twins. So look out for that particular email. Hopefully, again, you like this, send me an email, give me feedback, let me know how we're doing. And I'm looking forward to seeing all of you at the next webinar. With that said, have a wonderful rest of the day, wonderful rest of the evening to my friends over in Europe and all throughout the world. And I will see you next time. Have a good rest of the day. Thank you. Bye-bye.